You're falling right now. Not down, not in any direction you can point to with your hand, but you, your city, your planet, our entire galaxy are being pulled through space at roughly 600 kilometers per second toward a place we cannot see, cannot photograph, and can barely explain. It's called the Great Attractor. And for most of the 20th century, we had no idea it existed. Let's begin.
By the 1920s, we'd already learned that galaxies weren't just floating randomly. Edwin Hubble showed us the universe was expanding, that galaxies were rushing away from each other as space itself stretched. The farther away a galaxy was, the faster it should be receding. Simple, predictable, a clean, expanding universe. Except some galaxies didn't follow the rule. In the 1970s and 80s, astronomers mapping the motion of nearby galaxies noticed something strange. Galaxies weren't just drifting apart with the expansion of the universe, they were also moving sideways, drifting off the expected path, like the current isn't just pushing them outward, it's dragging them somewhere.
Our own galaxy, the Milky Way, wasn't just riding the expansion either. We were moving fast, along with the entire local group, Andromeda, Triangulum, dozens of smaller satellite galaxies, all being tugged together in the same direction. Something massive, hidden, was pulling on all of it. But here's the problem. When astronomers pointed their telescopes toward the direction of the pull, toward the constellation Centaurus, they found almost nothing. Empty-looking sky, a gap. Because directly in that line of sight sits the flat disk of our own galaxy, its stars, its gas, its dust, blocking the view completely. Astronomers call it the Zone of Avoidance, a band of sky where the light of 100 billion foreground stars drowns out everything behind it. For decades, whatever was out there, pulling an entire region of the universe toward it, was hiding directly behind our own galactic disk. You can't see the thing that's moving you. You can only see what it does. In 1986, a team of astronomers led by Alan Dressler and Sandra Faber, working with data collected across observatories worldwide, confirmed it. They'd been tracking the peculiar velocities of thousands of galaxies, measuring not just how fast galaxies were receding from us, but how their motion deviated from the pure expansion of space. And the pattern was unmistakable. An enormous region of the universe, spanning hundreds of millions of light years, was flowing toward a single point. They named it the Great Attractor. The math suggested something staggering, a concentration of mass equivalent to tens of thousands of galaxies, sitting roughly 150 to 250 million light years away, in the direction of the Centaurus and Norma constellations. Not a black hole, not a single object, a gravitational valley so deep that entire galaxy clusters are sliding into it, the way water slides toward a drain. Radio and X-ray telescopes, which can see through dust the way they saw through the Milky Way to reveal Sagittarius A star, eventually pierced the Zone of Avoidance. And what they found wasn't emptiness. It was a hidden supercluster, thousands of galaxies tangled together by gravity that had simply been invisible to optical telescopes the entire time. But even that wasn't the whole answer. In the years since, astronomers have found that the Great Attractor itself may be just a smaller feature sitting in front of something even larger. The Shapley Supercluster, one of the most massive structures ever mapped, roughly 650 million light-years away, appears to be the true prime mover, an even greater mass pulling the Great Attractor, which is pulling us. A pull behind a pull behind a pull. Then, in 2014, astronomer Brent Tully and his team mapped the full shape of the structure we actually belong to, not just the local group, not just the Virgo cluster nearby, an enormous supercluster of galaxies, 100,000 galaxies strong, stretching across 500 million light-years of space. They named it Laniakea, Hawaiian for immeasurable heaven. And at the boundary where Laniakea's gravity takes over from its neighbors, right at the watershed line, like a drop of rain deciding which side of a mountain to run down, sits the Great Attractor. Not the final destination, just the nearest visible slope in a much larger fall. Let's talk about scale, because numbers like these stop meaning anything unless you slow down.
The light we use to study the Great Attractor left its source 250 million years ago. On Earth, that's before the dinosaurs, before mammals, before most of the tree of life we recognize today existed at all. The single-celled and simple multicellular organisms of the Permian period were the most complex things alive when this light began its journey. Whatever we observe of the Great Attractor today isn't what's there now. It's an ancient echo, a 250 million-year-old snapshot of something that has already changed, merged, grown, shifted in ways we will never see in our lifetimes, or in the lifetime of our species, or possibly ever. We're being pulled right now by a shadow of something as it existed before life crawled onto land.
And it's not just us. Every galaxy in Laniakea, everything within roughly 500 million light-years, is caught in the same drift. Andromeda, the Virgo cluster, thousands of galaxies, billions of stars, unimaginable amounts of gas and dust and dark matter, all sliding, slowly, patiently, toward the same gravitational valley. Not fast enough to feel, not fast enough to see change in a human lifetime or 100 lifetimes, but undeniable, written into the velocity of every galaxy we can measure. We don't know exactly what's at the deepest point of that valley. We don't know if the Great Attractor and the Shapley Supercluster are the final answer, or just two more slopes leading towards something even larger, still hidden behind more dust, more distance, more time.
What we do know is this: the universe is not evenly spread. It's not a random scattering of galaxies drifting apart in every direction. It's a web. Filaments of galaxies stretched across unimaginable distances, vast empty voids between them. And at the intersections of that web, gravity pools into wells so deep that entire superclusters fall inward, generation after generation, for billions of years. We live on one strand of that web, and we are falling, right now, toward one of its knots. You can't feel it. There's no wind, no sound, no sense of motion. You wake up, you go about your life, and none of it feels like falling. But it is. Every star in the sky you've ever looked at, every galaxy you've never seen, held on the same invisible slope, sliding toward the same unseen depth.
We will never arrive. Not really. The universe is expanding faster than gravity can pull the largest structures together at these distances. Long before we would ever reach the Great Attractor, if we ever could, the expansion of space itself may carry potential destinations forever out of reach. We are caught in a current with no shore. So the next time you look up, remember, you're not just spinning on a planet, orbiting a star, circling the center of a galaxy. You are also part of something bigger and slower than all of that combined. Drifting, with everything you can see and everything you can't, toward a place at the edge of our maps, lit by light that left before there were eyes on Earth to see it. The Great Attractor. Unseen, unphotographed, undeniable. We don't know exactly what it is. We only know we're falling toward it. All of us. Together. Always.